Hi again, everybody. I just wanted to do an answer key for some of the Lesson 3 homework on absolute value equations. It was that photocopied sheet, page 294. And I got you to do numbers 1, 3. Remember, we crossed off 5 and 6, and we just said, let's do 1, 3, 7, 10, and 12. Alright, so starting with number 1, I'm going to do alternate letters here for starters. And so number 1 says solve for x, and A says the absolute value of x is equal to 5. And so we know that there's two equations that can come out of here. So the x can either equal 5 or the x can equal negative 5. And both of those have been solved for x already, and those are the solutions, because the absolute value of 5 is 5. Yes, that works. And the absolute value, excuse me, the absolute value of negative 5 is also 5, so both of those answers work. Let's try letter C. The absolute value of x minus 2 is equal to 7. Okay, so inside the absolute value bars could work out to 7, or the inside of the absolute value bars could work out to negative 7, and then when you absolute value that, you get positive 7. So those are the two equations. And if we solve these separately, we end up getting x equals 9. Okay, and the other equation is x minus 2 equals negative 7. And if we solve that, we end up getting x equals negative 5. And I think both of those answers are good. 9 minus 2 is 7. The absolute value of 7 is 7. Negative 5 minus 2 is negative 7. Absolute value that, and you get 7. So those are the two answers for 1C. And let's check out letter E here. It says the absolute value of x plus 1 is equal to 5. Okay, so the x plus 1 could work out to 5, or the x plus 1 could work out to negative 5, and absolute valuing either of those will give us 5. So this equation, we end up getting x equals 4, and the other equation, we end up getting x equals negative 6. And if you go and try them in the original up here, they should work. 4 plus 1 is 5. The absolute value of 5 is 5. Negative 6 plus 1 is negative 5, but the absolute value of negative 5 is positive 5, so both of those work. Okay, so this takes us to number 3. And why don't we try BDF this time, just for fun. The absolute value of x minus 2 is equal to 5, so we get two equations. X minus 2 could equal 5, or the other equation, x minus 2 could equal negative 5. In which case, we get x equals 7. And over here we get x equals negative 3. Going back in the original equation, 7 minus 2 is 5. The absolute value of 5 is 5. That works. Negative 3 in for x. Minus 2 is negative 5, but the absolute value of that is positive 5. So both of those answers work. Here is letter D. The absolute value of x plus 2 equals 1. Okay, so the x plus 2 could work out to 1, or the x plus 2 could work out to negative 1. In which case, we get x equals negative 1, or over here, x equals -3, and then go and check them out in the original. -1 plus 2 is 1. The absolute value of 1 is 1. That works. -3 plus 2 is -1, but absolute value of -1 is 1. So both of those work. Here's letter F. 4 is equal to the absolute value of 3 minus x. So the 3 minus x could work out to 4, or since it's in absolute value bars, the 3 minus x could work out to -4. In which case, this time we get -x is equal to 4 minus 3, which is 1. Divide both sides by -1, and we will get x equals -1. The other equation, we get -x equals -7. Divide both sides by -1, and we get x equals 7. Do both of these work? 3 minus -1 is 4. The absolute value of 4 is 4. Put 7 in for x. 3 minus 7 is -4, but absolute value would make it +4, so both of those work. Okay, so that's how you do number 3. Now, let's get on to number 7. In A, we have the absolute value of x plus 1. That equals x minus 1. So the two equations are x plus 1 equals x minus 1, or the x plus 1 could work out to the negative of the right-hand side, and then absolute value would make it positive. First equation, if we try to solve this, we are going to get 1 equals -1. Therefore, there is no solution. And in the second equation, we will get x plus 1 equals -x plus 1. Add x to both sides, and we get 2x plus 1 equals 1. Subtract 1 from both sides, and you get 2x equals 0. Divide by 2 on both sides, and you get x equals 0. Does this work? Here is the check. I don't think it works at quick glance here, guys, because we'd have the absolute value of 0 plus 1 on the other side, and we would have 0 minus 1 on the right side. So this is the absolute value of 1, and the right-hand side is -1. The absolute value of 1 is 1. Not equal. Therefore, we have to reject this answer. And we had no solution there. We rejected our solution in the second situation, so no solution overall. Okay, and if you want to see sort of a graphical interpretation of this, if we go math, go over to number, we could graph the absolute value of x plus 1. And then the other function is x minus 1. And we want to know where these two functions equal to each other, or in terms of the graph, where do they cross? So if we, absolute value of x plus 1, and then also the function x minus 1. And if we graph that, I'm going to fix the grid here in a second. Since we got no solution, we should see that these two graphs don't cross. So there's the absolute value graph, typical V graph, and then you can see x minus 1 is that straight line, and you can see that these don't cross. They do not cross, which means there's no solution. Okay, so That looks good for 7a. Here is 7c. We have the absolute value of 4 plus 3x equals 7x. So the two equations are 4 plus 3x equals 7x, or 4 plus 3x equals negative 7x. And over here, if we solve this equation, we will get 4 equals 4x. 1 equals x, so x equals 1 is a possible solution. And with the other equation, we are going to get negative 10x equals 4, so divide both sides by negative 10, and you will get x equals 4 over negative 10, which is a negative fraction. In lowest terms, that is 2 over 5. Okay. I'm just doing a quick glance up above. We're going to have to reject this one because it's going to make the right-hand side negative, and I can see that the left-hand side is going to be positive because it's the absolute value of something. Okay, so we're going to have to reject the negative 2 over 5. The x equals 1 seems to work because we would get 7 on the right-hand side, and 4 plus 3 times 1 is 7 in absolute value bars, which is equal to 7. So this one seems good. That one doesn't work. Okay, if you want to see a quick graph of this one, it would be the absolute value of 4 plus 3x, and then we're going to compare that with 7x. Okay, and there you can see there's just that one solution at x equals 1. If I do the intersect feature and I go close to that intersection, enter, 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 x equals 1, perfect, which is what we got. Okay, so that's how you do letter C. Okay, let's try 7e, everybody. X is equal to the absolute value of 4x minus 1. So the two equations are the 4x minus 1 could equal x, or the 4x minus 1 could work out to negative x. And with this, subtract x from both sides, and we get 3x minus 1 equals 0. So 3x equals 1, divide both sides by 3. X is equal to 1/3. And over here, why don't I subtract 4x from both sides? We will get negative 1 equals negative 5x. So x is equal to 1/5. Okay, I would encourage you to check, but on the surface to me they both look good, right? Now, if I do the absolute value of 4 times, let's check the 1 over 3 answer, minus 1, okay, that needs to be equal to x. That needs to be equal to 1/3 on the left-hand side, and it is equal to 1/3 when I fraction that, okay? So this answer is good. If I were to do the absolute value of 4 times, I'm putting 1/5 in for x, 1 divided by 5, minus 1. The absolute value of that is supposed to equal x, and x is 1/5, so this should work out to 1/5. 0.2 is 1/5. Awesome, so both of those work. And that's how you do 7e. Next on the list is number 10. And A looks like this. It says solve each equation, illustrate each solution with a graph that explains the results. The absolute value of x minus 3 equals x minus 2. So the two equations are x minus 3 equals x minus 2, or x minus 3 equals the negative of x minus 2. Notice it's the negative of the whole expression, so I have to put it in brackets. Now, the left equation gives us that little problem of negative 3 equals negative 2, therefore there's no solution to that equation. Let's see if this right one is any better. Distribute the negative. We will get 2x minus 3 equals 2. Add the 3 over. 2x equals 5. X equals 5 over 2. Does that work? Okay, on the left-hand side we have the absolute value of x minus 3, and x is 5 over 2, and then minus 3. So the absolute value side works out to that, and the right-hand side is x minus 2, 5 over 2 minus 2, that's also 0.5, so this guy works. Okay guys, also in number 10, we are supposed to illustrate each solution with a graph that explains the results. So I'll just try to do a quick graph here. We need the absolute value of x minus 3. That function, where is that equal to this other function of x minus 2? So there's the absolute value, x minus 3, and then there's x minus 2, and they have just that one meeting point. If I were to go and find intersect for you really quickly, just go close to the intersection point and I'll press enter 3 times. There's the intersection at x equals 2.5, which is 5 over 2. Okay, so that's what's happening with 10a. Here's letter C. The absolute value of x minus 3 is equal to x minus 3. So the two equations are x minus 3 equals x minus 3, or the x minus 3 could equal the negative of x minus 3. And over here, when we subtract x from both sides, we get negative 3 equals negative 3. add 3 to both sides. We get 0 equals 0. And remember back in Unit 3, that was coincident lines, so that gave us infinitely many solutions. And that makes sense because we do have coincident lines here. We've got x minus 3, that line, where is it equal to x minus 3? Okay, and over here we are going to have x minus 3 equals negative x plus 3. And we'll add x to both sides, and we'll add 3 to both sides, and we will get 2x equals 6. And we will get an answer of x equals 3. Okay, so on one side, infinitely many solutions. On the other side, just when x equals 3. And so graphically speaking, where do those two graphs meet? The absolute value of x minus 3, where does that meet the graph x minus 3? There's the absolute value graph, and then x minus 3 is that line there. Okay, and so they meet basically at x equals 3, and then at every other point beyond x equals 3. So it's actually infinitely many solutions for x being greater than or equal to 3. And you can see that like the way the graphs intersect on the graphing calculator. They meet at x equals 3, and then the lines are coincident from there. Okay, so final solution is basically all x values for x being greater than or equal to 3. And number 12, it says 3 of these equations have no roots. Which equations are they? Explain how you can tell. Okay, so A definitely does not have a solution because it's saying the absolute value of 2x plus 3 equals negative 5. Anything that comes out of an absolute value is positive. So how could it possibly equal negative 5? This is going to have no solution. Okay, another one that has no roots is letter D here. The only way these two absolute values could add together to give 0 is if they both work out to 0 from the same x value. But the x value we need to make 0 in the first one is 2, and the x value we would need here would be negative 3, so it's not the same x. So there's no x value that will make both of those work out to 0 at the same time, and so there is no way that this can have a solution because, again, a positive would come out of here and a positive would come out of here. If we're adding those together, we can't possibly get 0. So this has no solution. Okay, and it says 3 of these equations have no roots. Which are they? Explain how you can tell. I think the only other one is letter E, and this one is a bit harder to tell. Just by looking at it, it's hard to see that that doesn't have a solution, but if we tried solving it, the 2x plus 1 could equal x, remember the two equations, or 2x plus 1 could equal negative x. And when we try to solve this, we will get 1 equals negative x, divide both sides by negative 1, and we get x equals negative 1. And on this side, we get 1 equals negative 3x, divide both sides by negative 3, and we get x equals negative 1/3. And the original equation is that x is equal to the absolute value of 2x plus 1. And so imagine putting negative 1 right here and negative 1 here. We are going to, this will be negative 1, and this side, doesn't matter what you put in for x. I mean, technically you're going to get negative 2 plus 1, which is negative 1, but there's absolute value bars around it. Okay, so this side's going to be positive 1. Okay, which means negative 1 doesn't work. We'd have to reject this. And similarly, if I try the negative 1/3, if I were to put that in here, I would get negative 1/3. And then put the negative 1/3 in there. 2 times negative 1/3 is negative 2/3 plus 1. Which is positive 1/3, and then the absolute value makes it positive 1/3. Okay, so the left will always be negative, the right will always be positive, so we'd have to reject this as well, and so this one has no solution. Alright, there you go, everybody. Those are some solutions to the homework. By all means, send me an email if you'd like to see some more.